Today we're covering ordering numbers. We'll begin by approximating non-integers. Most integers, which include the natural numbers 1 through infinity, 0, and the negatives of the natural numbers, all those integers we're pretty familiar with. We've used them since junior high school, elementary school, preschool, and we're able to use them pretty fluently. We know that 3 is bigger than 2, negative 2 is smaller than negative 1, and so forth. So we're going to mainly focus on non-integers. So that's what we're really saying is these rational numbers. Let's begin with improper fraction conversion. So our first improper fraction is 5 over 5. If we go ahead and divide that, so I'll just make a section over here for our work. If we go ahead and divide that, 5 over 5 over 5 is really just 1. I find that by dividing 5 by 5, which is 1. The same thing is true for 7 over 5. So this is 1, comma, 7 over 5. I have 7 divided by 5. It goes in there one time. 1 times 5 is 5. When I subtract, I'm left with 2. That's my remainder. So this becomes 1 and 2/5. Notice my remainder becomes the numerator. My denominator stays the same. Let's do the same thing with 24/7. So 24/7. 7 goes in there 3 times. That's 21. I subtract 24 from 21 and I get 3. So I have 3 and 3/7. Same thing with 13/9. 9 goes in there once. I subtract and get 4. This is 1 and 4/9. Same thing with 8/3. So this is a way that you can approximate these improper fractions. Goes in there twice, which is 6. 2 is left over. So this becomes 2 and 2/3. What if we're comparing fractions that are not improper? I'm going to use some different estimation techniques. So what if I think about a number line? All of these numbers are between 0, we'll put 0 down here, and 1. That's what makes them fractions. They're between 0 and 1. So 3/8. Well, let's just break this in half for fun. This is 1/2. Is 3/8 above or below 1/2? Well, what's half of 8? That's 4/8. So if I say, okay, this is 4/8, 3/8 is just less than that. So 3/8 is going to be somewhere over here. Here's 3/8. How about 8/13? Well, if I break this into 13 sections, that means the halfway point, half of 13, is going to be 6.5. So this is 6.5/13. This is slightly larger than 1/2. 7, 5/7. I have 3.5/7. I'm going to write these below because they're hard to see up there. So 4/8 was half. These are all halves. So these are all halves. 4/8, 6.5/13, 3.5/7, 12.5/25, and 4.5/9. So we can see 4.5/9 is pretty close to 5/9. This is just barely bigger than 1/2. So here we have 5/9, just bigger than 1/2. Then we have 16/25, 8/13, and 5/7 that we're still working with. Okay, 5 is pretty far away from 3/5. It's 5/7 is almost 7/7. It's almost 1. So we'll put 5/7 down here. And then we have 16 25ths. So 12 and a half out of 15, 6 and a half out of 13. That compared to our 8 13ths and our 16 25ths. So let's compare these to each other. Which one's going to be bigger? Well, 8, if I double 8, so I double this, and I double the 13, I end up with 8 times 2, which is 16, over 13 times 2, which is 26. So I have 26 versus 16 over 25. Here's 16 over 25. This I converted to 16 over 26. So the way that division works, the larger the denominator, the smaller the number. If you think about pizzas, if I have two pizzas that are the same size, one has 2 slices and one has 3 slices, which pizza slice am I going to take? Well, if I want more pizza, I go with the pizza that has the smaller number. This has the smaller denominator, the smaller number of slices, so it is a larger number. So we'll plot that around here. 16 25ths, and just smaller than that is 16 26ths. So again, the bigger the denominator, the smaller the number is. So now we've ordered these. We're going to approximate square roots. I'm going to list the perfect squares. So here we have some perfect squares. 1 is equal to the square root of 1. 2 is equal to the square root of 4. 3 is equal to the square root of 9. 4 is equal to the square root of 16. 5 is equal to the square root of 25. 6 is equal to the square root of 36. 7 is equal to the square root of 49. 8 is equal to the square root of 64. 9 is equal to the square root of 81. 10 is equal to the square root of 100. And we can pause there for now. So I want to know, where does the square root of 15 fall? Well, square root of 15 is between the square root of 9 and the square root of 16. So this is between 4 and 5. So if I have my number line again, here's 1, 2, 3, 4, 5. Right here-ish, somewhere in between these is going to show up square root of 15. And it's probably actually closer to 4 because square root of 16 is 4. So probably around here somewhere. The exact location is not important, just that we know that it's between those two integers. Square root of 5 is between 4 and 9. So it's between 2 and 3. So somewhere in here is the square root of 5. Square root of 27 is between 25 and 36. So it's somewhere between 5 and 6. 79 is somewhere between the square root of 64 and the square root of 81. So that is going to be somewhere between 8 and 9. So square root of 79. And the square root of 54 is between 49 and 64. So it's between 7 and 8. This is the square root of 54. So now that we've practiced these ways of simplifying these integers, let's go ahead and order them on a number line. So we have negative 3.7. Well, here's negative 3. Negative 3.7 is right about here. Square root of 6. Well, this is really the square root of 1. This is the square root of 4. This is the square root of 9. Do that better. This is the square root of 4. This is the square root of 9. So square root of 6 will fall in between here. Not perfectly in the middle, but it's in between those two digits. 9 halves. 9 halves is the same thing as 4 and 1 half. So that's going to show up here. This is 9 halves. Negative 5/6. Negative 6/6 is 1, so negative 5/6 is almost negative 1. Example 2. 2.7 falls here. Negative 20 is in between the square root of, negative square root of 16, and negative square root of 25. So somewhere in here is negative square root of 20. 5 halves is the same thing as 2 1/2, which is here. And again, 2.5 is the same thing as 5 halves. Negative 5/9 is almost negative 1. So we'll put it here. Negative 5/9. (4.1) up to 4.1. Negative radical 3 is between negative radical 1 and negative radical 4. So it's somewhere in this range. It's in between those two. Negative 7/9 is almost negative 1. So this here, let me get rid of this radical. This here is negative 7/9. 16/21 is less than 1. So it's in between 0 and 1. 16/21. Example 4. Negative 1.6 is in between negative 1 and negative 2. Square root of 15 is almost the square root of 16, so it's right here. Square root of 16 is 4. Square root of 15 is just below it. Negative 3/8 is it's just a little bit smaller than 0. Negative 4/8 would be negative 1/2. So this is negative 3/8, almost halfway between 0 and negative 1. And then 15/4, 4 goes into 15, 3 3/4 time. So that's going to be right here, really close to this square root of 15. So this is 15/4. Let's move to example 5. Negative 2.1, slightly bigger than negative 2. Negative square root of 27. So down here, this would be negative square root of 25. So negative square root of 27 is going to be just to the left of that. Negative 15/9. 9 goes into 15 almost 2 times. That would be 18/9. So this is going to be negative 15/9. Then we have 2/21, which is just bigger than 0. Example 6. Negative 0.2, just smaller than 0. Negative 0.2. Radical 8 is almost radical 9, so it's almost 3. Square root of 8 is almost square root of 9. 5 goes into 12 2 times, and there's a little bit left. So that would be 2 2/5 when we divide this. 2 with a remainder of 2, so 2 2/5. That's going to be just right about here. So 2 2/5, or in other words, 12/5. But you know what? It's actually negative. I need to put it on the right side. So it'll be down here. Negative 2 2/5, or in other words, negative 12/5. And then 1/2 is just right here, halfway between 0 and 1. And we will go ahead and stop there.